All right, now I want to talk a little bit about Staiger and Kane article here. The title is interesting, Making Decisions with Imprecise Performance Measures. So what they're saying is the performance measures they're looking at are teachers' value-added scores, which of course means how well the students that they have taught gained in their academic learning over the past year with their previous year's academic achievement taken into account. So only that growth, that value added that the teacher supposedly provided for the student. Okay, and they're saying, they're admitting right up front that those value added scores for teachers are imprecise, and so they're saying essentially, should we make employment decisions about teachers using data that we know are imprecise, right? And they say in the abstract, critics often point to low year-to-year correlations in teacher value-added measures as a reason against their use. And that's basically, they're citing the Linda Darling-Hammond argument that I had you read first, right? So I'm not going to go through this in depth, but I just want to point out a couple things. All right, first of all, I think when you get to these questions, these are important questions that help orient you to the main idea of the article, 1, 2, and 3. And then I would say this section here, when you get to a statistical model of teacher impacts, more power to you if you read through this section, but you might just go la-di-da-di-da and go through this section right here, and then start really paying attention again down here. And when you get to the data, some of these tables are easy to read and some of them take some work, but I think if you can try to work your way through it, it's going to be very good. All right, so they do a correlation of year to year, and that's very similar to what I set up here. So year to year for each teacher. And they report some numbers here for various districts, ranging from 0.62 to 0.27. Now, correlational statistics can go from -1 to +1, with +1 being a perfect correlation in the positive direction. In other words, a good value added for 1 year will predict a good value added for the next year, and low. And the way of judging these kind of numbers is very similar to the rule that I gave you earlier in the semester for evaluating effect size. So 0.25 in correlation is considered pretty low and really is not a very good, then one score would not go well with the other score, or not often go with the other score. But a score of 0.65, for example, might be considered a moderately strong relationship. So in these data here, you have some low to moderate correlations. And one could argue that making an employment decision with low to moderate correlations is not very sensible. But then they, based on their statistical model, they predict that the correlations from 1 year to an average of many years is going to be much higher. And then they actually have the real data to see if their statistical model turns out to be accurate. And you can see it's highly accurate. And more importantly, the correlations are now much higher. So now we're ranging from 0.55 to 0.71, with quite a few of these closer to 0.7. So still not a tremendously strong relationship, but a pretty strong relationship. Now, I think that another table that I want to point to here that I think is a little more concrete is how teachers who were ranked in the bottom 25% on their first year of data did over a career. So if you're looking here, this is what percentage of those teachers were in the bottom quartile over their career. So the majority of the teachers who were low in the first year were low over their career. And then another good percentage were in the second best quartile, and then less in the third quartile, and less in the top quartile. So if you have a teacher that's in the bottom quartile in their first year, even though they might in a single year bounce up to be in the top quartile, over their career, they're very unlikely to get up to the top quartile. All right? And then they repeat the same kind of analysis, getting kind of more and more refined. So what if you were in the bottom 10% in your first year? Well, the numbers in the top quartile stay very low, but you notice you're also losing more in the third quartile, and there's a much higher percentage that are staying in the bottom quartile. So if you had a teacher that was in the bottom 10% in their first year, there's a really good chance that they're going to be a struggling teacher throughout their career. And then they get even more narrow in the way they look at it, and just look at the bottom 3%. If you're in the bottom 3% in your first year, even though you might have a good year every now and then, chances are very high that you're going to be in the bottom quartile throughout your career. All right, so I want you to work your way through this article. Even though I've given you the main idea, I think trying to understand exactly what they're saying here is going to be useful exercise. And then I want to tweak your curiosity with the reason that I chose this article, besides all the good examples of correlation and the fact that it's a kind of study that actually is possible for you to do. They get into this analysis here, and they ask kind of the question, so if you know a teacher is in the bottom quartile or has some low rating, are you better off firing the teacher or hiring a novice, given the fact that you know you don't know how the novice will do, but you know that novice teachers may sometimes struggle, right? And they're basically doing like trying to do fantasy football kind of idea of maximizing the instructional impact by placing your best bet on who's going to be the best teacher. So I just think that whole idea of approaching the decision in this way is an interesting thing to think about, and something that in the next module I'll ask you to think about whether or not you think that's an ethical approach or an unethical approach. All right, see y'all online.